Good evening, everyone. This is Christian Roberts. I'm back with another video, and today we are going to be talking about the medical treatment for Parkinson's disease, carbidopa in Parkinson's disease, and mechanisms and structural insights regarding the drug. So before I continue, I just want to go over the basics of what is Parkinson's disease. So as you should all know, a lot of people are more familiar with people who have an uncontrollable hard time basically shaking their hands or dealing with some type of stiffness. But I would like to go into detail. Basically, Parkinson's disease is a brain disorder that causes unintended or uncontrollable movements such as shaking, stiffness, and difficulties with balance and coordination. In other words, when the brain loses dopamine, which is a natural chemicals, which is due to loss of nerve cells in the substantia nigra, which is the part of the brain that contains neurons that releases dopamine to communicate with other neurons within the central nervous system. Symptoms usually worsen over time if not properly checked or diagnosed from medical clinicians. So I'm about to move on. So as I said, we all know Parkinson's disease. So now I'm about to get into what dopamine is. Dopamine is basically a chemical that helps regulate movement in the body. So, like it says up here, dopamine is a neurotransmitter that facilitates movement in the nervous system. When regarding Parkinson's disease, dopamine uptake would reduce, which will result into loss of brain function. So when Parkinson disease occur, as you see right here, when it's a normal neuron, all the dopamines are reaching out to each transmitter. But when Parkinson's taking effect, it is not as much dopamine being produced. So that's basically what happens during Parkinson's disease. As we continue on, now because people that's dealing with Parkinson's disease have lack of dopamine, there's this new prescription drug called Carbidopa, or also called levodopa or Lodocin. And basically, carbidopa is basically a decarboxylase inhibitor drug that is combined with levodopa, which is used to treat the motor symptoms of Parkinson's disease. This is to prevent further causes of lack of brain function. And as you see on the right side, you can see the molecular structure, basically the molecular figure of carbidopa, basically the synthetic version. And in other words, I also want to add on that levodopa is absorbed by the nerve cells inside the brain, which will turn to yield chemical dopamine, which is used to transmit messages between the parts of the brain and nerves that can control movement. So basically, in other words, the purpose of carbidopa is the purpose of carbidopa is to prevent levodopa to convert to dopamine outside of the brain. That's basically what the purpose is. Because, the central nervous system needs its dopamine in order for it to transmit, in order for the neurons to transmit and get in contact and message other neurons. So as we move on, I want to talk about the mechanisms of action of carbidopa. So as you see on this side, it says carbidopa prevents levodopa from being broken down before reaching the brain. The purpose is to block conversion of levodopa, like I mentioned before, to dopamine outside the central nervous system. It is to prevent unwanted levodopa side effects of other organs outside the central nervous system. So basically, once the DDC inhibitors, which is carbidopa, once it enters into the scene, then more dopamine is going to be produced out, is going to be yield. Just so the neurons could be able to contact with each other. So basically, this is the purpose of carbidopa, is to give that dopamine, give the brain the dopamine that it needs to continuously on to send messages and signals to each other. Otherwise, it will lead to either dementia, or it can lead to vivid hallucinations or just simple memory loss. So as we continue on, this is the X-ray crystallography and the chimeral structure of the carbidopa. And you notice how you see the C terminus and N terminus, and you see the structure is really an anti-parallel structure, pleated sheet. So you can see the structure and you see what it does. This right here, what you're looking at, inhibits the DDC, which is the decarboxylase that occurs if you're dealing with Parkinson's. So now we're moving on. This is the slide basically talking about the results of people who have, been prescribed or used carbidopa and levodopa for medication for that issue. And this is the results that and it has been reported that since the usage of carbidopa dopamine has been used, a lot of symptoms have been calmed down. Basically, majority of the people that have been dealing with Parkinson's disease symptoms have been lightened, have been basically monitored. So that means that the worst that their symptoms can be is the worst what they have right now. Instead of going further along. So thankfully that without this drug, a lot of people would have been in worse situations, in scenarios. And then keep in mind the age group of people dealing with Parkinson's disease is mainly occur from the ages between 50 to 85 years old. Also keep that in mind. And then this is my works cited. Basically, this is all the websites that I have gotten and received all my sources. And that's all I have to talk about today. I hope you enjoyed this presentation. I hope that you've learned what really Parkinson's disease is, and I hope you learned that there is a treatment out there. And if you know somebody who has been dealing with Parkinson's disease, you know exactly what type of treatment that you can get. Now, there is no cure for Parkinson's disease because, since this is regarding the neurological nervous system, but there are treatments to calm the symptoms down just so it won't be worse than what it is right now. So let's be grateful and let's keep in mind and make sure that if you feel something or if you have a family member that have certain symptoms of Parkinson's disease, be sure to contact your doctor first and if you go to the doctor one time and if you still need a second opinion, still get that second opinion just so you can be sure. But make sure you speak to a clinician before you take any steps. That's the only thing that I would like to say, whoever's watching, as far as what are future developments that could happen that could be given or granted over time. So I just wanted to present that out there. I'm grateful and I appreciate everybody who is tuned in. Thank you and have a good day.